All right, here's your trig review sheet. Let's do it together. It's always best if you can do it first, and then if you need support, so be it. Can you find the value of sine theta of this triangle? So it's opposite over hypotenuse. It's actually right there, right? How silly, right? But don't reduce it down. It's just 9 over 15. Can you find tangent theta here? The definition is opposite. Oh, I don't know opposite, but can I quickly find it? 25 squared take away 20 squared. So that's 625 take away 400. Square root of that is 20 is 15. So tangent is opposite over adjacent. So that's 15 over 20. Number 3. How about if I give you a trig ratio, could you find the missing one? So for this one, I'm going to draw a triangle. Sine is opposite over hypotenuse. So to find this missing side, it's 13 squared subtract 12 squared. So 169 take away 144. That's 25, and then the square root of 25 is 5. So what's tangent theta of this triangle? 12 over 5, opposite over adjacent. Cosecant's 5 over 3. That's the reciprocal of sine, so it's hypotenuse and opposite. 25 take away 9, square root of 16. 4. So cosine then is 4 over 5. Some calculator work. Can you find the measure of that angle? So if I want to know what this angle is, identify what you know in the triangle, opposite and adjacent. That's tangent. So the inverse tangent of 4 over 12, and then use your calculator. Make sure it's in degrees. Mine's in radians. So I'm going to change it to degrees. So do you remember how to change it to degrees? I know there's a bit of a shine here. Take this thing off. Is that better? No, still a shine. All right. Right there. Menu. No, not menu. Go back. Document. Then settings, and then setting, document settings, and then change it to degrees. Now find inverse tangent, and then type in 4 over 12, Control Enter, and the approximate angle is 18.434. Here, again, opposite and adjacent, so it's the same one, tangent. Inverse tangent, 3 over 10, and then use your calculator. So it's about 16.699 degrees. Can you find the measure of length of a side? So from this angle, opposite and hypotenuse, so it's sine 64, 11.5 over x. To get x by itself, I'd multiply and then divide. So in my calculator, I'm going 11.5 divided by sine 64, and it's 12.794. Can you find the missing side? So the angle opposite and hypotenuse, so again it's sine. Again, to get x by itself, multiply and then divide, and then type it in. and I get 47.884. All right, without your calculator, can you find each value here? So for the value of sine at 210, I need to know the reference angle. So I'm going to subtract 180, and the reference angle is 30. I need to know the point on the unit circle for 30, which is root 3 over 2 and 1/2. I need to know the definition of sine is the y coordinate. And then the last part, I need to know the quadrant. All students take calculus. So we're in quadrant number 3, and in quadrant number 3, only tangent's positive, so sine is negative. Pi over 6, the reference angle is 30. That is root 3 over 2 and 1/2 because of the denominator. We're in quadrant number 1, pi over 6, so everything's positive. And it's the reciprocal of the y coordinate. So the reciprocal of 1/2, it's 2. Cosine 210, we already did all this work. Cosine's negative, and it's the x coordinate, so it's root 3 over 2. 150, the reference angle, subtract 180, and the reference angle is 30. So again, it's root 3 over 2 and 1/2. Cotangent is x divided by y. So the x divided by the y gives me the answer root 3 divided by 1, which is root 3. What quadrant are we in? So in quadrant number 2, cotangent is negative. Sine and cosecant are the only ones positive there. The value of tangent at 0. So 0 is not a reference angle. It's right to the right on the unit circle, and that point is 1, 0. The definition is y divided by x, and 0 divided by 1 is 0. Tangent 2 pi over 3. Over 3 means the reference angle 60. The point on the unit circle at 60 is 1/2 and root 3 over 2. The definition is y divided by x again. So the y divided by the x is root 3 over 1, which is root 3. But I need to know the quadrant. So we're in quadrant 2 over 3. So 1 pi over 3, 2 over 3 is in quadrant number 2. And in quadrant number 2, tangent's negative. So it's negative root 3. 270 is not a reference angle. If you take 360 or 180, you'll get 90. It's at the bottom of the circle. And at the bottom of the circle is 0 and negative 1. The definition of sine is the y coordinate, so the answer is just negative 1. Secant at 210. We already did 210 here. So we're in quadrant number 3. We have... All right, thank you.
You're welcome.
So we need to know the definition of secant, which is the reciprocal of x. So if you take the x coordinate and do the reciprocal, you can leave it as 2 over root 3, but know that the answer is negative. You could also see this answer as negative 2 root 3 over 3. Same answer. All right, turn the page over. Use the point to find a trig value. So we're going to use some different definitions here. So to do this, I first need to find the radius. And the radius is the square root of x squared plus y squared. So 25 plus 11. And 25 plus 11 is 36. And the square root of 36 is 6. So the answer here then is the radius over the x coordinate. So it's negative. So it's 6 over negative 5, or negative 6 over 5. Tangent. Tangent is y over x. So I don't need the radius. So the y over the x. You could also write this like this, or you could write this like this. All are good. Y over x. Here, we need to know the quadrant. So in this one, we need to know it's a right triangle question, and we need to label it. And cotangent is adjacent over opposite. But what quadrant are we in? So notice that cotangent is a negative answer and sine is negative. So what quadrant are we in if sine is negative and cotangent's negative? Well, the only quadrant it could be is quadrant number 4, because everything is positive, sine is positive, tangent's positive. The only one where they're both negative is quadrant number 4. So I need to understand that when finding what I'm looking for. So find the exact value of the 5 remaining ones. So I'm going to label this. And I won't worry about the negative sign right now. So adjacent and opposite. The missing side here, the hypotenuse is 5. So just be aware as you do what's missing. So I'll go one at a time. So sine, we're in quadrant 4. So it's negative 3 over 5. Cosine is positive. So it's positive 4 over 5. Tangent is the reciprocal of that. So this is negative 3/4. Let's see if I have room. Secant is the reciprocal. So it's positive 5 over 4. And then cosecant, that's the reciprocal, negative 5 over 3. All right, let's try that again. So it takes some work to understand the quadrant. So all students take calculus. Secant is negative and sine is negative. So it can't be quadrant 1. It can't be quadrant 2. It can't be quadrant, wait a second. So secant is negative. Whoa. So let's try it again. So it can't be quadrant 1, it can't be quadrant 4, and it can't be, what else? Oh, and sine is negative. All right. So let's cancel them all out here. Boom, boom. So which is the only one that's left that it could be, where secant's negative and sine is negative? And it's quadrant number 3. So when we draw a right triangle, and we can just label it as root 7 and 2 and find the missing side. So root 7 squared and 2 squares, it's 7 take away 4, so this is root 3. That as I write these down, sine is negative, so it's negative root 3 over root 7. Cosine is the reciprocal, so it's negative 2 over root 7. Tangent is positive, root 3 over 2. What am I missing? Cosecant is negative, and it's negative root 7 over root 3. And then the last one, did I get them all? 1, 2, 3, 4. Which one am I missing? Cotangent. So the cotangent then would be positive, and it would be 2 over root 3. Notice I'm not even worried about rationalizing right now. Just understand your ratios. All right, I'm going to skip the graphing, and we'll do that last. So I'm going to go down to 27. Now, these questions we didn't have time to do in class. So I'm going to do them right now. Whenever you're doing inverse, these questions are asking for the angle that goes with that. So I need to know the definition and quadrants and different things like that. So I'm going to go through it with you. We're going to go through it with one of the lessons as well, because inverse trigonometry is a big part also of calculus. So I need to know sine and root 3 over 2. So sine is the y-coordinate. So the y-coordinate is root 3 over 2. If that's Batman, what's Robin? So the x-coordinate must be 1/2. And then what's this angle is what it's asking for. So the angle that goes with that point is 60 degrees. Or you can write it as pi over 3. For root 3, understand the definition is y over x. So the y-coordinate must be root 3, and the x must be 1, for when you divide, it gives you root 3. I also need to know what quadrant it's in. So all students take calculus. For inverse tangent, the definition is it can only be in one of those two quadrants. That would be 1 or 4. And in this case, it can't be 1, so it's going to be in quadrant number 4 by definition. Then I have to write it as a negative angle. So that actually makes it a little bit easier. So if I think of which angle in quadrant 1 does this go with, it's 60. But then you write this as negative 60 to be in quadrant number 4. A little bit tricky, but we're going to go through this again in one of the lessons. So can you work inversely? Reversely? The answer is 1. So what point gives you the answer 1? So the definition of tangent is y divided by x. So what point on the circle gives you that answer? And it's root 2 over 2 and root 2 over 2. When you divide them, that gives you the answer 1. And it's a positive answer, so it's in quadrant 1. And what angle goes with that point? And the answer is 45. So all of these are finding the angle that goes with it. Now, this is a composite trig, so there's 2 steps involved. So the first step is, what angle goes with the y coordinate being root 2 over 2? And the answer is 45 degrees. Then the second part is, what is the value of tangent at 45? We just did it, and the answer is 1. It's y divided by x. Let's try that again. In this situation, inverse tangent is 3 over 5. So I'm going to draw a triangle and label it 3 and 5, opposite and adjacent. To find the missing side, the hypotenuse, it is 25 plus 9, so that's square root of 34. What's secant of this triangle? Well, it's hypotenuse over adjacent, and you have your answer. Here again, you have the inverse of root 5 over 5. It's not on my unit circle, so I have to draw a right triangle and label it. So for sine, that would mean the opposite side is root 5 and the hypotenuse is 5. I want to find the missing side, so it's 25 take away 5, which is root 20. You can leave the answer as root 20. You don't have to simplify it. And then what's secant based on this triangle? Well, it is hypotenuse over adjacent, and just leave the answer as 5 over root 20. Hey, can you solve a trig equation? So to get sine theta by itself, you would add 1 to both sides. And when you add 1, negative 3 over 2 plus 1, that's like negative 1.5 plus 1. You get the answer negative 1/2. Then the answer is, what angles give you this answer? Now, in this situation, it's not an inverse trig question. Instead, it's a question that has an infinite number of answers. But we only want the answers from 0 to 2 pi. So I want to know, when is the y coordinate negative 1/2 somewhere on my unit circle? Well, the x coordinate could be positive or negative root 3 over 2. So what angle goes with that? So it's a 30-degree reference angle. So first of all, the quadrant. All students take calculus. If the x coordinate is negative, we're talking quadrants 2 and 3. Oh, sorry. If the y coordinate is negative, we're talking quadrants 3 or 4. And it could be positive or negative there. So which angles go with it? Well, what's the reference angle? Root 3 over 2, then 1/2. It's 30 degrees. So what's that in these quadrants? And because it's in radians, I need to figure out the answer in radians. So I need to count 30 degrees around it. So I know that's over 6. So we have 1 over 6. In quadrant 2 is 5 over 6. In quadrant 3, it's 7 pi over 6. And in quadrant 4, it's 11 pi over 6. Those are the two answers that give you the answer negative 1/2. Here we're going to divide by negative 8. So now we have cosine equaling negative 1/2. So now the x coordinate's negative 1/2, and the y could be positive or negative root 3 over 2. Understanding the quadrant, if the x is negative, then it's quadrant 2 or quadrant 3. Those are the two places for negative a half. This reference angle is 60 degrees. So my answer is going to have 3 in the denominator. Now, what angles is in these quadrants? So in quadrant 1, it's 1 pi over 3. This is going to be 2 pi over 3. And this is going to be 4 pi over 3. And of course, this one's empty altogether. Number 35, I'm going to teach you how to use your calculator to solve a trig equation. It's a little bit challenging because when you use your calculator to solve an equation that's trig, there's an infinite number of answers. So you need to know how to put in a domain restriction in order to get the answers you're looking for. So I'm going to teach you how to do that. So on your calculator to solve it, now first of all, my calculator needs to be in radians. So can you remember how to change it back to radians? So I'm going to go document, then settings, and then document settings, and then change it to radians. Now the next thing I'm going to do is I'm going to press menu, and then algebra, and then solve, and I'm going to type it in. So it's -4 cosine. You can use theta. I'm going to just use x as my unknown instead of theta, and then equals -3.72. And then I'm going to go comma x. Now, if I just did that, what would happen is I get an answer that looks so awful. It says general answer with ends in it and weird. Like, it doesn't give me a nice answer. That's because there's an infinite number of answers it could give me. So instead, when it's trigonometry, I have to put in the domain restriction. So I want you to go control equals, find the vertical line. We use it to evaluate, but we can also use it for a domain restriction. And our domain restriction goes from 0, and then I need to find the arrows on here. So I'm going to go, and I'm going to just type it in, less than or equal to. So I'm just going to type in, this side is x, not theta. And again, I'm going to put in less than, and then type in 2 pi. So it's telling the calculator to solve it only within that domain restriction. I just typed in what I saw in the question. So now when I press enter, oh, and it's not it's irrational. So I'm going to go control enter, and then I get 2 answers rather than an infinite number of answers. So the 2 answers are 0.376 or 5.906. That's just using your calculator and knowing how to put in a domain restriction. Let's try it one more time. I want to solve this with my calculator. So I'm going to go menu, algebra, and solve. I'm going to type it in. I'm going to use x instead of theta. And go comma x at the end. So type it all in. Then I need a domain restriction. So I'm going to go control equals, do the vertical line, and then type in the restriction. So it's the same one I just typed in. So it's 0, less than or equal to, x, and then less than 2 pi. Control enter. And my 2 answers are 1.035 or 2.106. Next, we're going to do some graphing, but I need some graph paper. So let me go get a piece of graph paper. I might need 2 pieces of graph paper. All right. So we're going to do 21 through 26. I think I can do 3 on one side of graph paper and then 3 on the other side. So let's do it together. So the first one for 21 is y equals 4 sine 2 theta. So I'm going to set up my graph to begin with. I'm aware that I have to go up to 4 and down to negative 4. So when I draw the graph, I'm thinking through, do I have room to go up to 4 and down to negative 4? I'm just going to go to 2 pi and negative 2 pi and just follow the pattern that happens. All right, so I need to know the amplitude. I said it's 4, and the period would be 2 pi, but we're going to divide by 2. So we're going to undo what's happening inside the function. So now the period is pi. Sine starts in the middle, and then the period ends at pi. And then in the middle between those is the third middle point for the wave. Midpoint, midpoint, midpoint. Then between the first two midpoints, it goes up to 4 because it's positive in front. And then the next two, it goes down to negative 4. And that's the pattern over and over again. So I'm just going to follow that pattern right now over and over again. And there it is. 22. Y equals 2 cosine theta divided by 4. We'll do it on the same scale so you can see what happens when the period is so long. So this one, the amplitude is 2, and the period would be 2 pi, but we're going to go times 4. It's 8 pi. It's a very long time to complete one cycle. The cosine starts at the top of the wave, unless it's negative, and then it would start at the bottom. So I'm going to start at positive 2. There's no way I can get to 8. In fact, half of 8 is 4, and I still can't even get to 4. So half of that is 2 pi, and that's going to be the middle of my wave. That's how big this wave is. And I'm going to follow the pattern on the other side. So every 8 boxes, we have something. So I can't even get to the bottom of the wave with the scale that I have. So it's the scale that I have. That's how long the wave is in terms of what we're doing. I could have changed the scale, but I just wanted you to see what happens on the same scale, how that wave got stretched out. All right, 23. Tangent. So I'm going to set this up. You course compress pause. The period here would normally be pi, but we're going to go times 3 to undo what's happening inside. And so tangent starts in the middle, and I'm going to find 3 pi. That's actually here on my graph way over here. So there's 3 pi. In the middle between them is going to be an asymptote. And there's my pattern. Now, what does the 4 do? In the middle between the point of inflection and the asymptote, so find the middle between there, you're going to go up to 4. 1, 2, 3, 4. And then in the middle here, you're going to go down to negative 4. And those give you the points to curve through to make your tangent function. All right, turn the page. 24. y equals 3 sine 4 theta All right, so sine starts in the middle. I know the amplitude is 3. The period would be 2 pi, but we're going to divide by 4, so it's just pi over 2. It's a very, very small period. So it's a short amount of time to complete one cycle. So find pi over 2, and that ends the cycle. So in the middle between them, we have 3 middle points. And then between the first 2 midpoints, we go up to 3, and then between the next 2, we go down to 3. So see how short that cycle is. So we're going to follow that pattern all the way across so that you can see it. So you can see how small that cycle is now quickly, like a heartbeat of a bunny rabbit going up and down, up and down. All right, 25. Y equals 2 cosine theta plus pi over 2. So we're going to set up our graph. Then I need to recognize something. So the amplitude here is 2, the period is 2 pi, but there's a phase shift here. And the phase shift is the opposite direction. So it's at negative pi over 2. That's where I'm going to start. So at negative pi over 2, I'm going to go to positive 2. And there's the start of my wave. That's the top. So I'm going to count 2 pi to the right. So that's 8 boxes to the right. And again, that's where it ends, at the top of the wave. And then in the middle between them, it goes to the bottom of the wave. So it starts with top, top, and then the bottom. Then, in between those would be the middle of the wave, and you have your pattern. And that's the pattern you continue. So I'm going to go 1, 2, middle of my wave, 1, 2, the bottom of my wave, 1, 2, the middle. Here too, 1, 2, the middle of my wave, 1, 2, the bottom of my wave, and then 1, 2, back to the middle, and then you have your wave, your curvy wave, and you're drawing it. All right, last one. 3 sine theta plus 3 pi over 4. So we know the amplitude is 3. The period stays at 2 pi because there's nothing multiplying inside that would change that. But we have a phase shift, and it's the opposite direction. So it's negative 3 pi over 4. So let me set up my graph, and then I'll graph it. Of course, you can do it and press pause, and then when you're done, see if we match. So the first thing I need to do is find where negative 3 pi over 4 is. So it's negative 1, negative 2, negative 3 pi over 4. Sine starts in the middle. There it is. Then we have a period of 2 pi, and in our scale that's 8 boxes to the right. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. That's the end of my cycle. And then in the middle would be in the third middle point. So I'm going to count in the middle there. Now in between the first 2 middles, so it's 1, 2, 3, so it's 1.5, it goes up to 3. And then in between the next, which is 1, 2, wait a second, that's not right. In between, 1, 2, 3, no. In the middle between them, I'm missing a count here, so it's 1, 2, 3, 4. Anyways, here is the middle. there, not in the middle of the box. And here, not in the middle of the box. It goes down to -3. So it goes up to 3 and down to -3. And that's the pattern I'm going to continue. So if I feel the pattern is off, I'm thinking, what did I count wrong with my scale to get this not symmetric? It needs to be symmetric. The pattern needs to be consistent. So I'm going to count 1, 2, 1, 2. That's the top of my wave. 1, 2, that's the middle of my wave. 1, 2, that's the bottom of my wave. It's at -3. -3. 1, 2, the middle. And then 1, 2, the top of my wave. 1, 2, 3. And that's it. And you've graphed some trig functions. So, Mr. G Math over and out. Good job doing your homework. Trig review. I know it's tough. We'll get through it together. Promise.